So we're going to talk about document visual AI with 51. Again, this is going to be like a practitioner kind of focused session in the sense that we're going to be, getting hands-on with some code and kind of thinking about how to work with some of these models. So we're not too in depth in theory. And again, the slide deck is short. It's just going to be covering what we're going to discuss. By the way, my name is Harpreet Sahota, hacker in residence here at Voxel 51. I've been here for almost 2 years. I've been doing deep learning stuff for, I think at this point, maybe 4 or 5 years, something like that. Prior to that, I've worked. All my jobs have primarily been like math and code. I've worked as an actuary, a biostatistician, and then at various startups that were kind of deep learning tooling focused. If you decide to connect with me, if you think that what I was talking about is interesting and you want to hear more of what I was talking about, what you could do is go ahead and connect with me on these platforms. So I appreciate you guys joining me as I share stuff, what I'm learning and whatnot. So today's agenda, we're gonna work with a really interesting data set that I created. And I'll give you a little bit of background about like kind of the data set source, but we're going to start with PDFs and we're going to take those PDFs and we're going to parse this into a 51 data set. Now, to create a 51 data set, you need some type of visual kind of media to create that data set. So we're going to go from the PDFs and we're going to create images. Then we're going to parse some metadata with those images, and then we're going to construct our 51 data set, and then we'll do some little bit of visualization of that data set within the app. Then we'll go into a little bit of interesting workflows using some what's called visual document retrieval models, but really they give you the end product of these models is they give you embeddings, and so we can start doing some really interesting embedding based workflows. And then from there, we'll talk about how to use some OCR models and kind of inspect what the output of those OCR models are. And then we'll talk about how to evaluate these models. So first thing, this webinar, this workshop's going to be in 4 parts. The first part is all about getting started. So what I'm going to do is, give you a notebook or show a notebook where we download and extract PDF documents, convert those into images, create a 51 data set, parse it with some metadata, and then do some mapping of categories to kind of make our exploration easier. Everything here is on GitHub, and I'll give you a link to the GitHub after the session. Once we've constructed our data set and we've got a 51 data sets, we're going to move into embeddings-based workflows. So here we're going to use a model called Gina Embeddings V4. I like this model because it's nice, lightweight, quick at inference, and it gives us some pretty good representations. We'll compute embeddings for our PDFs that were converted to images, and then do various embedding-based workflows, showing you how to use 51 to do that. And then with those embeddings, we can start doing some really interesting kind of more kind of in-depth analysis of what is in our data set. From there, we'll show you how to use OCR models within 51. So we're going to use a couple of well, the notebook I'm showing you is only going to use one model. It's called Miner U 2.5, but I'll link out to other models that we've integrated into 51 that you're going to be able to use, and the pattern for usage is going to be exactly the same. Every model that I link to has a very in-depth README to show you how to use that model, and then we'll see how we can use OCR models to do kind of grounding, so text grounding. So we'll end up with like bounding box detections, but then also just like full text extraction. And then, I'll show you that we're actually not limited to using VLMs that are specifically tailored for OCR. We can actually use kind of a standard or more vanilla VLM to do some OCR extraction as well. And in this case, we're going to use a model called Moondream V3. And so I'll show you various things that we're going to be able to do with Moondream V3. Finally, the last part is doing a little bit of evaluation. So we'll show you how you can quickly evaluate how well your kind of OCR models are doing, and then we'll evaluate some of those zero-shot classifications that we had created as well. So specifically for evaluation, what we're going to look at is a few metrics that are kind of what we use when we're kind of evaluating how well an OCR model is. The average normalized Levenshtein similarity. That's kind of the standard metric. So we'll compute that. We'll talk about some other metrics as well. For example, exact match, character error rate, and word error rate. And then I'll show you how we can evaluate these zero-shot classifications in FiftyOne. Then also, once we've done all this, we'll within the FiftyOne app, we'll create some really interesting dashboards that allow us to really understand our data set kind of at a more deeper level and find out kind of how these models are performing. So let's go ahead and get coding, right? So before we do that, the actual data set that we're working with is a data set of NeurIP's papers. So if we go to NeurIP's papers, right? I think it's NeurIP papers downloads, something like that. Yeah. So what I did was initially I went through all these papers here, right? So I scraped this website, NeurIP's papers, and we get some really interesting information when we do this, right? So we get these, all the papers that are there, as well as kind of like their title, the authors, and then the abstract of that paper as well. So what I did was went through all of these, downloaded and scraped this website, got all the papers and all this information, then went to archive and scraped some additional information from archive, and then filtered that down to only papers that are kind of like visual AI papers at NeurIPS. So that's kind of like the, I guess the provenance of the data, like kind of where it originated from, how I constructed it. And the product that we're going to work with is the first page of the PDFs for those visual AI papers. So now I'll go ahead and share this GitHub that we're going to be working with today. And so this GitHub will kind of outline everything that we're working with and everything that we're going to do. So all the various notebooks are all here. Then also kind of show you how to get started, right? So how to install the dependencies and all that for what we're going to be using. Everything is open source that we're using here, right? So to install FiftyOne, it's just pip install FiftyOne. The models that we're using, they're open weight models. Some of them might have kind of commercially restrictive license, but that's okay. We're just kind of understanding what's what these models are capable of. FiftyOne has a plugin ecosystem, and you'll see kind of some of that in action today as well. And then we'll go into kind of how to build these data sets. So at this point, I'll see if there are any questions for me. If there are questions, I'll go ahead and happily take them before we get started. All right, so don't see any questions here so far. Great, so let's go ahead and just jump right into code, right? So that's what we're going to be doing with this session. We're just going to get right into code, and we'll start with the first notebook here. All right, so let's go ahead and share this notebook here. All right, and so if you do have questions, the best thing to do is make use of the Q&A widget. I see some people actually are making use of that, so that's great. So questions here are starting at the bottom. Can we not directly use documents for OCR? Most of these vision language models, they need that visual component, right? So they will need to have, because you need to have, like if you're using a vision language model, at the end of the day, you need to have tensors, right? So you can't easily go from PDF to tensor, and so you need some type of intermediate, kind of representation for that, and that is the document image. So that's why we can't go directly from document to OCR. Some models are multilingual. There's a lot of multilingual models. You could read the kind of specifics on these models and what they're trained on, and their capabilities as well in the various readmes. I don't know off the top of my head which ones are multimodal, which ones aren't. And older engineering books, depends on the models. Most modern OCR models that are kind of VLM models are actually good at technical language, and older engineering books, you can get models that do really well outputting latex and things like that. So the other question that we have here is what embedding database will be used? Sorry, is the screen all black? That's kind of weird. All right. How about now? Is that better? Sorry about that. All right, cool. Hopefully you guys can see everything. I don't know why it was all black. That's weird. Um, all right, cool. Uh, Embeddings database. In FiftyOne, you can use a variety of vector embedding kind of databases. You could use Quadrant, LanceDB, what have you. I'm just going to use the built-in scikit-learn backend for our embedding, so I'm not making anything complicated here. I just trying to make it as easy as possible. Uh, so just we can, kind of get started and kind of see what is possible. So no really complex backends for the embedding database or anything. Just strictly using scikit-learn as the backend. All right, so let's go ahead and get started here. All right, so I'll share a link to this GitHub repo that we're working with. This is going to be right here in the chat. Let's send it to everyone. And this is the repo. So you can take this repo after the session and work through it and maybe, use your own data sets and kind of build off of it. Do make it kind of as complete as possible for you to get up and running and kind of show you step by step everything that you need to get done. So the first step, of course, is creating a data set in FiftyOne. So what we're going to need to do is first install our dependencies, right? So you'll install FiftyOne in PDF to image. And I mentioned this in every single one of the notebooks is to download these plugins because we're going to be making use of these plugins. Everything's open source. FiftyOne has a robust kind of ecosystem for plugins, and the plugins allow you to kind of extend the functionality of FiftyOne to really customize it for what it is that you're doing and what you're working on. And you'll see some of that in action. But what we're going to start off by doing is downloading a data set from my Google Drive account, right? Data set will end up looking like this. You'll have a JSON file and you'll have the zip of all the PDFs, right? This takes about 2 gigs of disk space, so just be aware of that. And then once you unzip the data set, what we end up with is a bunch of PDFs like so. So we can open up a PDF and kind of explore that here, right? Should be able just to click on it, right? And we're able to kind of click around and explore the various PDFs. And of course, like if you're trying to find interesting papers for yourself to check out at NeurIPS, having to do this kind of one by one, clicking through every single paper, trying to figure out what's in there, it's a cumbersome task, right? I was able to filter down to about 1,134 papers that are visual AI papers at NeurIPS. And so, it's cumbersome to kind of parse through it in this way and kind of figure out what interesting research is being presented. So why don't we try to get this data set loaded into FiftyOne, right? We'll start with the PDFs as I've shown here. And as I mentioned, in order to create a FiftyOne data set, what we need to do is first convert these into images. And so that's what we're going to do with this code. Here, I'm going to take all these PDFs that we see here, and I'm going to create PNGs with them, right? And the PNGs here just are basically now images of the actual PDFs that we have. So this is step 1, right? Once we do that, what we're going to do is look at all the metadata, right? And so just to give you an example of the metadata that is associated here, just kind of looking at this, I believe we can just do that. The metadata that we have associated with each one of these papers, we've got the type of acceptance it is, so whether it's poster, workshop, so on and so forth. We got the title. We got a link to the NeurIPS poster as well. we have the speakers and authors, we have the abstract that we pulled from NearIPS, we have the archive ID, and this archive ID is actually, when I constructed this data set, I was searching the archive API by the paper title and by the authors, and then from there getting the archive ID and extracting then the category of that paper as well as the authors. So that's kind of what's going on here. So this is what the metadata looks like, right? And then to construct a 51 data set, a lot of folks here said they're not familiar with 51, what it's useful for, and how it's used. So what 51 allows you to do is take all of this visual media you have and kind of view it all at once. That's, at a high level, the first value prop of 51 is to do this, is to visualize your data set and see what is in there. And the way 51 works is that these things that we create, this 51 data set with these samples, they're actually all backed into a MongoDB database. You don't need to know anything about MongoDB. When you install 51, pip install 51, all of that gets set up for you right off the bat. And the actual data set and the database itself is not that big. It's just a few kilobytes. And once we have our data set in this MongoDB, it allows us to do some really interesting types of queries against that data set, really complex, interesting queries against that data set. So what this cell is going to do is first we'll instantiate an empty data set, right? We'll pass this parameter overwrite equals true. What this means is if I already have a data set that exists with this name, let's just go ahead and just overwrite it, right? Because maybe you might want to start over from scratch, or maybe something happens while you're importing the samples. Something happens, you don't want to run into any issues. So let's just go ahead and just pass override equals true. So if a data set with this name exists already, we'll overwrite it. Persistent equals true. We'll set this true because we're going to want to access this data set in later Python sessions. And so that's what persist equals true allows us to do. Otherwise, the data set kind of evaporates after you terminate your Python session, right? And then what we're going to do is we're going to construct a list of samples, right? And how we construct this list of samples is we'll iterate over this JSON with the metadata. We'll grab the archive ID. We'll grab the path of that file, and that path is going to be this right here, right? And we'll construct samples, right? So a 51 data set is comprised of samples. So the atomic element in a data set is something called a sample. And that sample can have all sorts of metadata associated with it. And then also something interesting called 51 labels. And 51 labels, as you'll see in a few moments here, allow you to do some really interesting filtering over that data set. So what we're going to do is just parse some metadata. We'll parse the type, the name of the paper, the URL for that paper on archive, the entire abstract of that paper, the archive ID, and then the list of authors as well. And then we'll start with our first classification category, which is the archive category. And so the archive category here is essentially, when a paper gets submitted to archive, it falls into one of several categories. We'll see the human readable category names later, but some of them might be image and video processing, or multimedia, or robotics, or computer vision, so on and so forth, right? So that's what we're parsing here. And what we're going to do is construct this list of samples. And then once we have that list of samples, we're going to add all of these to our data set. We'll compute some metadata. The metadata will give us information such as like the file type, its size in bytes, as well as its dimensions, its resolution as well, right? Now, once we do that, we have a 51 data set. So with this 51 data set, we can actually call the data set and get some interesting information about it. So the data set I've actually already have loaded. So what I'm going to do is load it locally and show you what we're working with. So NearIPS vision papers, right? So if you have a data set already constructed in 51, all you got to do is add this. Right, and we'll load that data set, import 51 as FO, right? And once that's loaded, will kind of see this data set and what it's all about. All right, so I see a question. Somebody had their hand up. No need to put your hand up. Just if you have a question, go ahead and drop it right here in the data set. Sorry, in the data set, in the chat. That'll be much appreciated. Before I go into this, I see a question in the Q&A. Should the images have the same format? In scientific papers, you have the same structure. If you don't have the same structure in the document, I don't know if I understand that question. If by same format, I mean, I parse everything as PNGs, right? So, you know, it depends on your use case, right? Like, our documents can have any format, right? Doesn't matter. Once we have it loaded in FiftyOne as a data set, doesn't matter what the format is, we can still do interesting things with it. We can still compute the embeddings using a document, visual document retrieval model. We can still compute OCR. It doesn't matter. Once it's an image, pass it to the model, and you can just do all sorts of stuff. Question here, can you explain from the token perspective later on? I don't know what you mean by that. You captured the image of static alphabet letters. Can you capture a moving letter? I mean, that would be a video, not an image, right? Some OCR models might work on videos, but for the most part, most of them will just be, you know, static images. Question coming in here, is FiftyOne an API wrapper on top of vision language model? No, FiftyOne is a kind of FiftyOne integrates vision language models, right? Like the tool FiftyOne itself is a way for you to interact with and work with visual data sets. And it's extensible, so you can have integrations within FiftyOne, and I'll show you a bunch of these integrations that allow you to very quickly use the FiftyOne idiomatic kind of Python API to really quickly run inference with a few lines of code against the samples in a data set. So that's what FiftyOne is, and hopefully you'll kind of get a better mental model as we go through this. So how do you capture the structure of a document, headings, subheadings? Well, that's what some document models, as you'll see, are really good at. So we'll get there in notebook number 3. FiftyOne is FiftyOne is a way to work with data, and it integrates with various VLMs. That's basically true. All right. If you have regular one-off comments, just use the chat feature for that. Actual questions you can drop in the Q&A. How do you handle scanned images? So do you measure any spelling mistakes, or are they just ignored? That's a good question, and I think maybe we'll cover that in the evaluation notebook. You know, once you have a image scanned, and assuming you have ground truth with that image, then you can evaluate it directly. If you don't have ground truth, then maybe you pick the strongest model you possibly can, and then just compare that model against other models, and then select the one that has like the lowest inference cost or whatever, based on its performance against that strongest model. You know, so when a vision language model is running OCR, it's pretty much just extracting the text that it sees on that document image. Regional languages, some models do, some models don't. You know, it just depends on the model and its capabilities and the data it was trained on. All right, cool. So that being said, you know, ignore all this stuff. We're going to talk about all this stuff later here. But once we have a FiftyOne data set, you'll see that we've got, you know, each sample has an ID, file path, metadata, so on and so forth, and then all the different fields that we had parsed from the metadata, right? And just to kind of show you what one sample in FiftyOne looks like, we can go ahead and call the sample. So every sample in FiftyOne looks something like this, right? It points to the file path where that image lives on disk. It has metadata associated with it, like I told you, size, meme type, and the resolution. And you can see we're working with some pretty large, you know, documents, and you can adjust how high of a resolution you want for the images you create by just changing this DPI parameter. I set it arbitrarily high just to get, you know, as best output as possible, but of course you can set that to a lower amount too, and that'll change the resolution of those images and the quality of that document image that you end up building. And you can see here, Now we have everything parsed on the sample level, the abstract, the archive ID, the authors, the category, all that stuff. We have it all kind of parsed here. Once we have that data set, we can start doing again some really interesting queries at a very high level. So here, we could just do a quick count values on the the archive category label. So we could see that this category we have 22 papers, this category we have 20 papers, this category so on and so forth, right? It might be better to actually have human readable kind of values for this category, so we can quickly just map the archive category to a human readable name, right? And that's what we're going to do here in 51. So we're going to just clone the sample field. So saying everything here, let's just go ahead and create a new field on the data set called archive category mapped. And then this is the mapping that we're going to use. And let's go ahead and map everything into this kind of mapping. Now we can call count values on that, and we get a better sense in a more human readable kind of format for what we have. Now we can go ahead and open the 51 app and kind of inspect what's in the data set. So what I'm going to do here is actually, this is a data set that we end up working with a little bit later on in the session after we do some enrichments to it. So what I want to do is actually just load this data set. And I might have to, yeah, I've got a couple of different sessions loaded here. So what we're going to do is I'm going to do this. I'm going to close my terminal down. And we're just going to go ahead and launch an app with the data set that we have. And this is going to work in your local browser, right? So this is how 51 is going to work. So of course, the demagogues are always going to be a little bit unfair when you're doing a live demo and things will break. So what I'm going to do is I'm going to launch it via the terminal. And while this is coming up, is it good with math heavy documents? Again, depends on the OCR model, right? The capabilities that a model has is basically dependent on the data set it was trained on, right? So if the data set that it was trained on was math heavy or had like a bunch of whatever type of document you're interested in, then that model will have those capabilities as well, right? So again, that's why it's important anytime you look at consider a model, is you get a sense of its training data mix, right? Because that will tell you the capabilities that it ended up learning. Another question here, is 51 the same to image data as pandas is to test? Yeah, basically. And that's a really funny thing that you say that, because if you go to our 51 docs and you go to pandas, I guess if you type in pandas versus 51, we have like a guide that gives you pandas cheat sheet. And kind of, if you're coming from the world of pandas and you're really familiar with pandas, then you can understand kind of how 51 and pandas compares like so. But yeah, that's a good way to think about it. All right. So this is the data set that we're working with, and this is kind of what we have right at this moment, right? We've not done any type of enrichment to the data set so far. This is just the data set as we've parsed it. And we could do some type of just high-level interesting filtering in 51. Of course, you could filter by label. So let's say you just want to get the image and video processing papers, and we can kind of look through that and kind of see everything here, right? We can open up a sample, and with the Caption Builder plugin that I had you guys installed, we can read the abstract as well. And see kind of side by side here. This will be useful when we start using other OCR models as well. So at a high level, this is what you're able to quickly do with 51, right? Some other interesting things that we can do. I had you guys download a dashboard plugin, so you can add plots to this app. Let's just say we want to do like a categorical histogram. And let's say I want to do a categorical histogram on the authors, and I can say count of authors, right? And we can sort this by frequency. And this can give us a sense of, okay, uh, which authors, at least which authors have like the same name, right? Some names might be similar, so it might be different, or, this author might have actually had 7 papers accepted. So let's see who this person is. So we can click on this, it's interactable, and this will filter down to all the papers that have this person, Ren Ri Zhang, listed as an author, right? And you can see, okay, we can make this sample grid a little bit bigger, and we can see, okay, is it actually, the same person? Ren Ri Zhang, are they, you know, doing research in a lot of the same topics? So this is a way for you to do that. So of course you can filter again, just by clicking on that making that dashboard, creating the histogram, and then filtering and then clicking based on that. So these are all papers that have this person listed as a author. So we can go ahead and clear that out. And to this dashboard, of course, we can add another item, and maybe an item that we want to add to the dashboard could be another categorical histogram, and maybe we want to do something like we want to plot the mapped labels. So you can say category distribution or something. You can make it up as you'd like, and you can sort it by frequency, right? And then we can create that plot, right? And once that plot is created, we can let's just auto scale this, and we can click in and say, okay, let's see, there are 20 papers on with the archive category of image and video processing. So we can click onto that, and you'll see that simultaneously the sample field, the samples panel will filter, and then the authors plot will filter as well. So we can see, okay, we've got 20 papers with this category, and these are authors that have multiple papers. So we can say, okay, who is, this person who seems, has a unique name, so it must be the same person, right? And we can see what 2 papers this person has, right? So they do fast MRI and MRI stuff, right? So you can see kind of a sense of what their research topics are. So before I move on to the next notebooks where we start doing some more interesting stuff, I'll see if there's anything in the Q&A session. All right. Questions coming up here. Can I use local deployment? Yeah, so everything that we're working with right now is just the local version of FiftyOne. So like you see here, like I'm working on localhost. So no data has left my personal computer at all, right? This is all just local. Everything's working locally right now. There is a enterprise version that allows you to do, work with teams and work beyond just the local computer, where you can access stuff on the cloud and do permissions and all that type of stuff. And that can be on-prem, that could be in cloud, however you want to do it. But everything we're doing is the open source local version. So yeah, if you got sensitive information using everything locally, this data isn't going anywhere. Okay, so question here. PDF image, FiftyOne app launch, mathematical. Yep. This is, well, we've only done, we've not done analysis of OCR or anything yet. That's coming further down the line. But we went from PDFs, went to images, loaded everything to the app, and done some initial kind of exploration within the FiftyOne app. Now we're going to do some more in-depth and more interesting exploration. So I'll go ahead and clear this out, and we'll move on to the next notebook. In this notebook, I linked to a bunch of different data sets that we have hosted on Hugging Face, which are parsed into FiftyOne format for you already. So if you go to huggingface.com/voxel51, right, if you go here and you scroll down here to data sets, you can get a sense of the wide variety of data sets. But for example, like I linked to each one of these individually, but common forms, consolidated receipts, so on and so forth, right? So these are the different data sets that I've got parsed into FiftyOne format. so you can get a sense of the types of different labels and stuff. We'll get to bounding boxes and stuff a little bit later, but if you want to quickly try to find a data set that's similar to the types of data sets you are working with, and see how these models perform on those types of data sets, I've got a variety of them in FiftyOne that you can, quickly use before, trying to maybe parse your own data set into FiftyOne format. So that's what we got here. So we've got a data set, we've got to load it into FiftyOne format. Now we can start doing some really interesting stuff with it. The first interesting thing we could do is start using embeddings, right? So I don't know if anybody here is going to NeurIPS, but I'm going to NeurIPS. CVPR is definitely my favorite conference. NeurIPS is a close second, but there's a lot of papers, a lot of research, and it's hard to find what's actually going to be piquing my interest in the stuff that I'm interested in, right? So kind of the scenario I want to work with, kind of the context when we're talking about working with embeddings here, is this scenario where we've got all these papers we're trying to go through. We only got a few days at NeurIPS. What papers should I prioritize, right? So this is what we're kind of going to try to do with these embeddings, right? So let's figure out how we can narrow down our search. So the first thing we do is visualize the data sets, right? We're going to, we've loaded our data set already, put it into FiftyOne format. What we're going to do then is start using embedding models to kind of see if we can find interesting clusters of research at NeurIPS. I'll show you in a second. The plan right now is I'm going to just go through this notebook, and then we're going to run back to the app, and then we'll start seeing how to do stuff in the app. But once we have our document images, we can then compute embeddings for those document images, and then come up with like some semantic kind of clusters or groupings within that data set. Then we could do some semantic similarity search, try to find novel work, and then we can, from there, maybe build a schedule for ourselves for this conference, and for finding things that we're going to be interested in checking out, right? So for this, there's a few things that we'll need to install. Of course, FiftyOne, assuming that you are starting brand new and fresh, like I've got a link up here for opening collab. So if you're starting a fresh new collab session, make sure you install all this stuff. If you're working locally, you can load your data set just like so. I've already actually parsed this data set and put it onto Hugging Face. So if you're working in a fresh notebook, what you could do is just download the data set as we have seen it up to this point, straight from Hugging Face Hub. All right. And then what we're going to do is just start with embeddings, all right? We're going to compute embeddings for our entire document collection. So this is a one-time operation that's going to turn each document into just a vector, which is a mathematical representation that'll capture kind of the visual and semantic meaning of that document image. And so to do that, we're going to register our model source. So this is a model that I've integrated in FiftyOne. So we register the zoo model source. So this is just saying pull all the code from this repo, and then we load the model. So we instantiate the model itself. And then to compute the embeddings, it's just one line of code, right? Dataset.compute embeddings. We pass in the model and the field where we want to store our embeddings. And you could check the dimensions of your embeddings like this. Now, of course, running models needs GPUs. It takes time. So I'm saving you time. I've actually already run the embeddings models and hosted this here on Hugging Face. So this model you could find, this data set you can find here. So you can go ahead and download that data set, and it'll have the embeddings for you, right? Now, once we have our embeddings, what we want to do is visualize them, right? Because embeddings by themselves, as interesting as they are, become more useful when you can do kind of interesting math on them and interesting visualization. So what I'm doing here is computing visualization. And essentially, this is performing dimensionality reduction with UMAP under the hood, right? And then as you'll see when we open the embeddings panel, each dot is going to be a document, and then documents that are kind of visually or semantically similar end up being close together in this embedding space. And this tells us, we do this without, telling the model anything about the document or the categories. Just, we have that model look at the content of that document image and cluster them together essentially, right? Then what we're going to do is build a similarity index, right? And so what the similarity index allows us to do is actually then perform natural language search over those documents. And you'll see how to do this in the app. And again, this is all non-trivial stuff that we're able to do with just a few lines of FiftyOne code. So we'll create a text similarity index. And you can just compute similarity real quickly via the SDK, but you can also do it in the app as well. And I'll show you how to do that. And what we can do now is actually some really non-trivial embeddings-based workflows. And we're just doing some interesting math with those vectors that we've created. So the first thing we're going to do is compute this uniqueness score, right? And this uniqueness score tells us how different or unique each one of these papers are from all the other papers. And we can interpret the scores as follows here, right? If there's a low uniqueness score, then what that means is that maybe this paper is not that different from a lot of the research that is being presented in our data set as we've collected it. If the uniqueness score is high, that might be, okay, well, this is different from everything else, maybe worth checking out and seeing what it's all about. We can also compute, duplicates, or in this case, near duplicates based on those embeddings. So this can help us, if we think about how we're looking through papers and trying to figure out what paper we want to prioritize reading. Right? If there are papers that seem similar to each other, maybe we want to read only one or two of those papers and not the rest, right? So with this, computing kind of near duplicates, we're avoiding this redundancy of having to look through a bunch of different papers and whatnot. And we can make our scheduling process a lot easier. And so here, just real quick, is a table that will summarize the difference between duplicates and uniqueness. So before I move a little bit further here, there's a question coming in. I struggle a bit with defining embeddings, like how to define links, for example, chapter, text, selection level, so on and so forth. Okay. So with the way these models work, these visual document retrieval models, right, they all have a preset size for their embeddings, right? We'll take that document image, we'll run it through the model will do what it does, typically chop it up into patches, compute tokens over each patch, aggregate those tokens, and then give us a single vector representation for that entire document, right? So that's kind of what that paper does. And for this use case, what we're trying to do, it makes sense for us to do that. Can you go more granular? Yeah, I mean, if you want to compute embeddings for each individual section, you could, but is that high value or not? I don't know, right? Like, I don't necessarily think that is super high value. If you just want the semantic context of an entire page, that would work. So yeah, it depends on your use case, depends on what it is that you're trying to figure out. We're using the first page of each paper. Yeah, we're using the first page of each paper. One, because, well, downloading every single paper would get me banned from archive. And two, that's a lot of documents. And three, high level cursory kind of understanding, right? Mostly when I look at papers, the first thing I do is read the abstract, right? And the abstract is what's the most high value signal for me to determine whether or not I want to go ahead and continue reading this paper or not. So for this purposes, using the first page is perfectly okay, because that give me a sense of, what do they present typically in an abstract, the novel contributions, a little bit about what they're, what's unique about what they're doing, and basically tells me why I should read the paper. Essentially, that's kind of what the abstract tells me. All right. So I want to say that we're not limited to only working with visual embeddings in FiftyOne, right? You saw that when we parsed our data set, we actually had a field on there that was called abstract. So that was the abstract as we pulled it from the NearIPS website. So I can also compute embeddings for those abstracts as well. So text embeddings, and then visualize those in the FiftyOne app. And you'll see all this in just a second here. But I'm going to use here the Gina v3 model to compute text embeddings. And you can see how quickly you're able to do that in FiftyOne. We just instantiate the model, iterate over the samples in the model, grab the abstract, run the inference, and then compute visualization. Right, so that's what we do for the text embeddings there. Another question coming up here. If we use the whole paper, would it be possible to have only one embedding vector for a multi-page paper? I mean, yeah, if all of your pages are one image, that could be possible. Or what you could do is, you can compute embeddings you can compute the embeddings on each page for each paper, concatenate all of those embeddings, so you just end up with a really long vector representation for the entire paper, then do dimensionality reduction on that. If you wanted to visualize it, you could do that, yeah. Or, when you do like this high dimensional math on that really large concatenated, vector, you can just, you don't necessarily need to do dimensionality reduction to compute uniqueness or representativeness or near duplicates or anything like that. So that's one thing you can do. You can concatenate every single embedding for every single page. So that's one thing you can do. Great. So another couple of other interesting non-trivial things that you could easily do with FiftyOne is compute representativeness. So this just helps you kind of find the most prototypical document images in your data set, right? So these give you kind of like, what are, a score that just tells you how average a paper is, I guess, right? And when we visualize the app, we'll color by representativeness, and you'll be able to see that some clusters of documents might have very high representative score, which means that this paper is really representative of this kind of area of research. And this will all be very clear once we open the app and how we can start digging through this. So just really quickly showing you how to do this really non-trivial math in FiftyOne with just a few lines of code. Next, what we're going to do is that same model that we use to compute those vector embeddings, we can use it to compute, or rather perform zero-shot classification. And that's what I'm doing here. Trying to see, okay, how good is this model at, it is a model that is used for visual document retrieval, but I can match the similarity between the vector embedding of that document image and a archive category, and see if that model is capable of discerning, how similar that document images embedding is to that category embedding, right? So this is something that we could do. Right, so we'll show you this in just a second here. But we do this both with the kind of the unmapped category, so that's that non-human readable one, and then the human readable as well. Right. Now we're going to turn to the app in just a moment here, but I encourage you to perform this same workflow that I've shown you with one of these other models as well. So of course, some of these models are big, 7 billion parameters, 3 billion parameters, so on and so forth. So you'll require some GPU support for that, but a couple of them are smaller. And so you might be able to get away with using CPU for that. Now that being said, what we're going to do is I'm going to turn now to this here. This has a bunch of stuff on it that we have not yet gotten to, so I don't want to spoil the surprise here. For right now, let's just go ahead and focus on embeddings, right? So first and foremost is, we created embeddings for, where did that go? There's multiple data sets I have on my machine that have the same name. There we go. All right, so we computed embeddings, and we can see that this is the embeddings just based on the visual document retrieval models. And we can see some type of clusters that emerge, right? So for example, like we have a island of papers here, right? And we can go ahead and zero in on that island of papers and kind of look through them, right? And we see here all of them are kind of papers that deal with like out of distribution type of training, right? So everything here is has something to do with out of distribution. confused about how embeddings are handled. Uh, are we chunking them or concatenating them? So this is basically what we've done so far. When we did 51, when we use 51 to compute embeddings all the way up here, where is it? Compute embeddings, right? So this gives us a vector representation for each document image, right? Then to visualize that, we just do dimensionality reduction, right? And that's what we've done here. We've done dimensionality reduction. And that allows us to be able to visualize this in the app, right? So each one of these dots here represents one paper, right? So we haven't concatenated anything or done anything besides dimensionality reduction at this point, right? So that's where we are. Will we be finished in 3 minutes? No, this thing was supposed to go on for I think an hour and a half, so we'll be hopefully finished in half an hour or longer. But this is recorded and it will be on YouTube. But I do hope you stick with me till the end. All right. So now what we can do is actually color by some of the values that we computed. So for example, we can color by uniqueness score, right? And we get a sense of which papers are kind of really unique. And what's interesting is that the papers that are really unique tend to just be in a space by themselves. But if we kind of pan here, right, and we look through this little cluster of papers, perhaps like down here, what we could do is we could see that this little cluster of papers, well, let's just look at this one, right, has some papers here, and then some of them are highly unique. So what are these highly unique papers, right? So for example, this one opens large-scale architectural CAD dataset. Okay, that's pretty interesting. So all these papers seem to be based on CAD. This one might have CAD in its title, but doesn't seem to be actually talking about CAD. But this gives us, kind of a sense of what's going on here. Of course, I'm going to try to breeze through as much as possible here, but I encourage you to look through this more deeper and plan out these embeddings more deeper. We can color by uniqueness. We can also color by, in this case, it was representativeness. So let's go ahead and clear this out, and we can find kind of papers that are more prototypical or representative of a cluster. So if we go down here, so if you look at all these papers here, so these papers, right, they are kind of in a cluster, and we can see, okay, the ones that are highly representative are these of that cluster. So maybe we start by reading this paper, get a sense of what this kind of cluster of research is about, and then from there maybe branch out and find more interesting papers to check out. So we've done all this just based on the document embeddings, and let's see how nice the demo gods want to be to me. This might take a while because I don't think I've loaded the model. Okay, so a couple points here, right? When you try to do natural language search in the app, this spins up a separate Python process. And in that Python process, in the background, we have to load that model. And then, loading that model takes a little bit of time. And then we have to run inference from that natural language query against that model, compare to all the vectors, representations for all these document images, and then filter down to the most similar ones, right? Of course, this is a 3 billion parameter model. I'm not running on a GPU, I'm running locally on my Mac. So this might take a while. So this might actually break on me, but hey, you know what? It's worth a shot. But let's say I'm interested in papers about 3D object detection or something, right? We could do this natural language search in the app. The first time you do this will always be a little bit slow, and that's because we are having to load that model in the background and do all that stuff. So it's still kind of cranking away, but we can come back to that as it's kind of loading the model and doing the inference against that text query. The next thing we could do, of course, we computed text embeddings, so we can now visualize based on text embeddings. And it looks like we might get a little bit more tighter clusters compared to the document image embeddings. But that is interesting as well. You'll notice that we didn't do any type of computation for uniqueness or representativeness or things like that. But the text embeddings, I leave that as an exercise for you to do. So I encourage you to go ahead and do that. But the same kind of thing, same workflow here. You can go ahead and filter down on samples and kind of find stuff that are interesting, or figure out kind of what is in that particular cluster, right? So you see here, this is still taking a little bit of time, so I'm going to move on to the background. We'll let this compute in the background because, again, like I mentioned, it has to load the model into memory and do its thing. But high level overview of what we could do with embeddings based workflows. I encourage you to check out all the detail that I have here for you. And then also in the README for this repo, I link to a talk that I did actually last week that went really in depth on document retrieval. So I've got the slides for that, the entire YouTube presentation, and then the GitHub repo. So I encourage you to check that out and learn more after this session. Now what I want to do is actually just get into how we can use OCR models in FiftyOne, right? So this is still, of course, cranking in the background. We'll see if we're able to get anything a little bit later. But I want to just show you real quick how we can use OCR models. So if you're working in Colab, of course, make sure you install the dependencies and make sure you install these plugins. And we'll see particularly this Caption Viewer plugin in just a few moments here. We've seen the dashboard plugin at a high level already, so you see what that's capable of. Load the dataset locally. If you are working locally and doing all this stuff locally, just load it like so. Now I have loaded this dataset, pushed it onto Hugging Face. This version of the dataset will have all the images, all the embeddings that we've computed, plus all of the OCR results. And this is, I did this for your convenience because these models take forever to run. And I'll explain why it takes forever to run in just a second. Dimensionality reduction that we've done, good question. In the previous notebook, I used UMAP for dimensionality reduction. You could use tsne if you'd like. You could use PCA. Those are both methods that are built into FiftyOne. If you've got a custom reduction method, you can use that in FiftyOne as well, and just point the visualization to the results of that. But yeah, UMAP tends to work best for images. That's kind of the one that is recommended for images. So that being said, show you real quick how to use OCR models with your document images. Here, what we're doing, again, like I mentioned, loading the data set that already has all the stuff. I'll save you a bunch of time. And what I'm going to do here is use this data set called, this model called MinerU. It's a 1.2 billion parameter VLM. And so all of the models that I've implemented into FiftyOne, these are all the transformers implementations of these models, right? So using the transformers library from Hugging Face and transformers API. Why transformers and why not VLLM? I have yet to successfully compile an environment with VLLM and have a successful install with VLLM. Maybe it's because I'm not smart enough, or I don't know, but I've yet to have a successful build for VLLM, right? And if it's causing me that much grief to set up VLLM, then I'm guessing that it might be difficult for the community as well. And since a lot of these model integrations that I have are basically for kind of prototype use cases and just showcasing the pattern for how to integrate a model into FiftyOne, I'm okay using transformers, right? And so that's why we use the transformers implementation. So here I'm using MinerU, and it's a model that does support batching. And even with supporting batching, of course, I ran this on a Google Colab GPU, an A100 with 40 gigs of GPU RAM. So I used a fairly large batch size. And the CPU instance I had also was high RAM CPU, so I used 8 workers. Even then, running this inference here against the 1100 something papers in the data set took well over 9 hours. Right, so it was a lot of compute going along with that. Same thing here. Right? It took a very, very long time. And something that's interesting, right? Like if And can anybody think about, okay, look, looking at a document image, right? Why do you think it would take a vision language model so long to run inference against one of these papers for whether it's grounding or whether it's extracting text, right? There's a few characteristics about documents that are kind of cumbersome. One is like just you could patch this document up and you get a lot of white space, right? So there's a lot of white space that is hard to kind of, it just takes up space and computation time. It sucks. It's just what it is. Also, you have to generate tokens for each word in the actual document image itself, right? Not only that, but then whatever special tokens or tags that that model emits need to get generated as well. So one, you know, document image can have outsized amount of tokens, right? Especially if you're asking it to do some grounding or if you're asking it to do some type of just text extraction. Whereas if you just, give that model tell that model just to output one word to summarize the paper, it will be a lot quicker because it just needs to create that one token. But when you're doing detection or extraction, there's a lot more than just that one token, right? There's a lot more than just the tokens that we see on the actual document image. So there's a lot of, it's autoregressive in nature and it just takes a lot of time because of that. What else I show you to do here is, we're not limited to just using VLMs that are specific to OCR. What I've done here is actually used Moondream 3. Great model, I love it. Very, very powerful model. And I use Moondream 3 to extract the abstract from each one of the documents. So I just prompt it with, hey, just give me the abstract from each paper, right? And I get the abstract. Then I also use Moondream 3 for zero-shot classification, and we'll see the results of this later. So this right here in Moondream 3 took, 5 hours to run on that A100 GPU. This on Moondream 3, since I asked it just to respond with one category, this took about an hour, hour and a half maybe on an A100 GPU. Again, just because it has to output just that one token, right? So this notebook showed you how to run various OCR models, and I link you to a number of different OCR models as well that you can check out. That being said, let's go ahead and now filter, see everything in the app here. So I have a lot more than just the what I've ran in the actual. Let me just do this. Let me clear this. I want to make sure that I'm showing only the text extraction. That's the raw text extraction, the abstract from Moondream, the abstract from NanoNets, as well as, am I losing something here? There should be some. So I have multiple versions of the same data. Okay, this is the one that has all the text extractions. All right, great. So just let's hide these out of the way here. All right, cool. Yeah, text extractions, and then the minor U text extractions as well. So text detections. These are actually I didn't show in this notebook how to use DeepSeek OCR. I linked to DeepSeek OCR here. DeepSeek OCR will have the exact same kind of usage pattern as what we see up here for minor U. It's the same usage pattern where we register the zoo model source, instantiate the model, and then DeepSeek OCR the transformers implementation doesn't support batching, so no batching there. But you'll click on any one of these links, look through the README, and it'll tell you exactly what you need to do. But we've done now here OCR with grounding, right? So we could see that these models are fairly good at, detecting kind of text and, each of them, like for example, let's say here, this is all the minor U detections will have a label for that. That's a title, that's text, that's a side text, so on and so forth. It'll give us a label for the type of text, and then actually the text content in that detection as well. Same for DeepSeek OCR. We can see what it's detecting. You see the DeepSeek OCR actually misses the footer, and it misses like this kind of aside text, but it grabs everything that is inside the actual, I guess, the paper itself. So it does miss some stuff. When I used DeepSeek OCR on this, I just used the base model size. There's a much larger model that's a lot more powerful that you might want to check out. But you can see here, like, minor U gives us, like, not only does it tell us, okay, these are images, we get bounding boxes around the images, bounding boxes around the text, image captions, right? So we get really rich kind of grounding of the grounding and parsing of that document image, which I think is pretty cool. Now, what we could do is actually on each sample, we have the caption viewer plugin. And you can see here that I've got some text fields here. So why don't I just open multiple of these, right? And let's just do this. Let's open this. That's here, caption viewer to the side of this, and let's compare and contrast a couple of models. So let's see. I have a text extraction from, here, let's close this out first. Text extraction, I have the, this is going to be the text extraction from a DeepSeek OCR. Am I frozen? Are you guys able to see what's going on? Like, my image looks frozen. My picture looks frozen, but hopefully you guys can see what's going on. All right. Yeah, so, all right. All right, good, I'm good. All right, so let's see, text extraction. So I have a little bit of backstory for the struggles, right? In order for me to get everything that I needed for this workshop done in time, because I told you how long these things take to run inference, I had to open multiple sessions in Colab and run inference and push stuff to Hugging Face. The final result on Hugging Face is exactly as you need it, but my intermediates that are local on my computer are all over the place. So I apologize if you see some oddness. This is just a artifact of me doing stuff in a weird way. But that being said, let's go ahead and open up a couple of things here. So let's do text extraction with a couple of different models here. So we're using the caption viewer plugin here. The text extraction I'm looking at on this pane here, this is the text extraction from the DeepSeek OCR model. This is another text extraction from the NanoNets model, right? And the caption viewer will parse the caption, or rather parse the output as the model gives it to us, right? So we can see how NanoNets, for example, is giving us the output, right? So it's giving us this markdown format. It's telling us there's a watermark up here. It's telling us that there's, this is a very large heading, right? So we get that markdown format with NanoNets. And perhaps that is important to you or interesting to you. Perhaps it's not. And we can see DeepSeek OCR doesn't actually give us that same kind of rich markdown or that structure that we get with NanoNets. So this is just a couple of things to see here, and as we can kind of compare and contrast the outputs of models using the caption viewer plugin, and comparing it against the ground truth, right? And get a sense of, okay, how these models giving us output, right? If having this type of, for example, on the right side here, with NanoNets, if having that kind of markdown output is important, then you should probably go with that. model, right? Because perhaps it's a bit more faithful to what is on the content of that document image than DeepSeek OCR, for example, right? This gives us a high level kind of overview of that. That's probably slowing down the app a little bit. Um, and we can compare the Moondream abstract to the abstract here and see how well it did, right? And we'll get a little bit more granular on evaluation in just a second. But this is a quick and easy way for you to see, okay, the results of your OCR model, compare them, and kind of visualize them in the app as well. We still save on the data set itself, kind of like the raw output field. So you can see the nanonets text here. You can see kind of like the raw output with all the tags and the things like that. How it's parsed. Same thing with the OCR model, DeepSeek OCR model as well. But the caption viewer just renders it faithfully as to how it shows up on the screen, right? So let's see if this Gina embeddings works here now. Like you do natural language search here. Let's say papers with a diagram. This might not work in the background, but we'll see. I'm probably going to crash my computer by the end of this. But anyways, that's what we're working with here for OCR models and how you can kind of understand what's in an OCR, what the output of an OCR model is. Next, let's go to evaluation, right? I'm just going to leave that as is. All right. So we're going to use a what's called the text evaluation metrics plugin. And it's a plugin I created to help us kind of understand the performance of OCR models. And it computes a few different metrics for us. We're already familiar with all this here, so let's skip over that. But a few metrics that we are able to compute are, for example, ANLS, the average normalized Levenshtein similarity. This is kind of like the primary metric to evaluate VLMs for OCR. And so the way this works as a FiftyOne plugin is you first download and install the plugin, which is just this pattern right here. And in FiftyOne, they're called operators. And so with one line of code, or one function call rather, one operator call, you'll pass in the data set, the field that you're trying to, the predicted field, the ground truth field, where to store the outputs, and then also the other arguments for that. And so the metrics that I implement with this plugin, there's the average normalized Levenshtein similarity. This just normalizes edit length by the string length. And again, very common for measuring OCR and OCR performance for VLMs. We can also do just exact match, which is basically exactly what it says. Does it exactly match what it is that, do the strings exactly match, right? So now, of course, this becomes cumbersome now, or a little bit of a challenge now when you are working with the output of a VLM that has a lot of special tokens to denote kind of where an image is and where and other things are, or an image is not, for example. So exact match might not be the best. So maybe do normalized similarity with the average normalized Levenshtein similarity. But either way, you have these metrics available for you in the plugin. So you can run them via the SDK just like this. A couple of function calls. We do the character error rate, so just the ratio of character level edits to go from one string to from the prediction string to the ground truth string. Word error rate, very similar, but we're just doing it on the word level. And what we're going to do is actually now show you how to do everything in the app, and then we're going to create a couple of scatter plots, particularly two scatter plots. We'll do the ANLS against the character error rate, and this is what I deem to be kind of like the most important kind of thing to look at, because ANLS is threshold based, so it's kind of binary-ish, and then CER is continuous. So we'll be able to see some interesting relationships, specifically, high level OCR quality and character level edits, and we'll get some really interesting insights with that, as well as with word error rate versus character error rate. So I'm going to go ahead and just let's show you how to do this in the app. So I showed you that the code and the SDK and all that, so you can do all that there. But you can also, once you have the app open, hit the backtick operator. And then once you have the backtick operator, what you can do is hit text. And then in the app itself, you can select, one of the things that you want to compute. Let's say we want to compute ANLS. The prediction field is going to be, let's just say it's the Moondream abstract. We'll just do abstract from Moondream against the ground truth abstract. We'll just leave similarity threshold as is, and let's make it case sensitive, right? So we'll go ahead and do that. We'll hit execute, and then we'll end up with a value for the ANLS score as it's kind of computing in the background. So if we refresh the app, it should pop up here. Of course. So yeah, it's a little bit of a downside here working with this locally is I'm doing this without kind of a proper MongoDB setup. Kind of like I'm hacking stuff together right now, so it's giving me a little bit of grief there. So let's go back to that data set. Which one was it? I believe it was this one. Yes, we have the Moondream abstract. All right, cool. So yeah, just showing you could do all that here, right? You can compute exact match, compute normalized similarity, CER, so on and so forth. I'm gonna just do it really quickly in the app here. So I'm gonna load this data set, and because I don't feel like entering in all the stuff from the operator field if I already have the stuff done. If I already have everything done in the SDK, I don't want to go through and have you guys watch me fill out the operator fields, but just showing you that each one of these operators has its own field. You select, right? And this is all written in Python. Everything here is done in Python. And so I'm extending the functionality of FiftyOne to kind of suit my own workflows. And so again, fully open source. You can see all the code for that. If you ever want to build a plugin and need help, like I'm more than happy to help you. But let's go ahead and just do all of these. And so I'm going to run all of this. And then we'll go ahead and just refresh this. If I refresh it from here, it's probably going to crash. Nope, we got everything here. So you see we have all the scores here. So yeah, I shouldn't refresh the app like that. So this is kind of like the more kind of proper way to do it. It's create the session and do that, but then I have like several different sessions running, and I don't want to mess up my other stuff. All right, cool. So we see here, we've got all these scores here. What we're going to do is, again, just use the dashboard. And I'm just going to create some histogram plots real quick. And let's do numeric histogram. And we'll say distribution of ANLS. And you could rinse and repeat this for each one of these metrics. But we'll do it here. And then maybe the number of bins we want to do is maybe, let's increase the number of bins until we get stuff that is interesting and wait, I'm not using the right data set. Sorry, should be using this one. There we go. There we go. All right. And we'll do Moondream ANLS score. Let's do maybe like, I don't know, 100 bins. Maybe that's helpful. ANLS score. Right. We can go ahead and create that plot. And I'm actually most interested in this. Like, why do I have this many, you know, documents that have an ANLS score of 0, right? What does ANLS score tell us again? If we scroll up here, remember that for ANLS, right, we need returns 1 if the similarity is greater than the threshold, otherwise returns similarity score, right? So we want this to be as high as possible. So we can drill into here and see, okay, why are these not, like what's going on here? So let's go ahead and do this, and we can pull up the Moondream abstract. And of course, this is one of my broken data sets that I have locally, which all have the same name. But we can, yeah. If you guys run this in your local machine or on Colab and you don't have multiple data sets all pointing to the same thing, it'll be a lot smoother for you, I promise. But yeah, we're able to drill down and look into that. Just make sure this is the right one. Yeah. Right. And then again, let's just show you. Okay, so we're saying we want to do these scatter plots, so ANLS versus character error rate. So we can, of course, add to this a dashboard, a item, scatter plot, right? Maybe the Y, we can make the ANLS score. And the X, we can make the, right? And create that plot. Add another item. Let's do another scatter plot. We can do CR versus WER. And we can do down here the CER, and then here the word error rate. And right. And so now we can start getting a sense of model performance, right? Like we could say, for example, here, like here's papers that are, here, what is this one paper that gets like a super high score, right? And it tends to be, this one. Of course, your data set, when you pull it from Hugging Face, will be clean and fresh, not muddled up like mine. But the point being is that you can, kind of interact with these dashboards and really, use the lasso select and maybe, go down to subsets, and this filters everything down. Then from here, you get a sense of, okay, you get this distribution of scores. You can open up the actual document itself. You can, for example, just compare what you see on the actual document to, what you see from, let's see how broken this data set is. Yeah, this is, yeah. And you can actually compare and contrast and kind of see what's going on there. So I'm officially up on time, but I covered everything I wanted to cover. I know I didn't get too in depth or anything like that, but at least give you a sense of what you can do now, right? So you're able to now go from raw documents and raw PDFs, raw documents, to images, to a FiftyOne data set, compute embeddings, visualize embeddings, do a bunch of interesting kind of math over those embeddings. You can run OCR models. You can then visually look at your actual document image with the OCR output, assess visually how that's doing. You then have a set of routines or utils for quantitatively measuring how well that model is at OCR. And just to pull it up, and no, we didn't get to this far in, but we can also evaluate the performance of zero-shot classifications. So using this code, you'll be able to, just very quickly evaluate how well the classifications are. So I should have some here already. So for example, I didn't evaluate the classifications for the Moondrew model yet, but just, using the zero-shot embedding model. So here we can see how well using the mapped categories, how well, in this case, Gina embeddings v4 did. We could see the metric performance individually, the summary, we can see class performance, we can see the confusion matrix and drill down. Okay, like these are papers that, for example, were confused by the model. You can drill down here and get a sense of what those samples were and visually inspect those. Of course, you can also compare models to each other. So with this mapped eval, I didn't run the code is there for you to do it, but I did not run Moondream eval, so you can compare and contrast those two. You can do scenario analysis, right? So you can get really interesting and in depth for how you want to perform analysis of your model performance. All right, cool. I know I'm over time. I went through every notebook that I wanted to. Hopefully this was useful. Hopefully this is helpful. Hopefully you learned a lot. The notebooks are there. You can follow along with all the code. Spend some time with it. I covered in 1 hour, what typically might take you an entire kind of morning to do, right? You might spend 4-5 hours kind of really going in deep and inspecting how well your models are performing and things like that. So that being said, are there any questions here? There are questions, in fact. Is it possible to have a link to the transcript? You'll get the link to this video soon. The link to the GitHub with all the code is here. Victor, let's get in touch. We'll get in touch. I'll save your information there. What's the advantage of using the minor year DeepSeek over Azure Document Intelligence? That's a good question. Okay, so I'm just really interested in all the new stuff that's happening, right? And I love open source AI. I love open source models. So new things come out and they're local. I can run them, locally. I want to hack around with it. I want to play around with it. I want to see what's on the cutting edge. And then, the only cost I have incurred is whatever my compute cost is to run it locally. I do have a GPU rig that is available for me to use. If you have Azure Document Intelligence or Google Document Intelligence, I haven't built any plugins for those, but if there's enough interest in that, I could build a plugin for that, and you can easily do all this stuff using Azure Document Intelligence or Google Document Intelligence as well. Bear in mind that when you use those services, your data goes to them, right? So maybe you don't want that. Maybe you're working with sensitive documents that you want to only keep, very secure or on-prem. Use local models for that as well. Cool. Well, thank you guys for hanging out. I know we covered a lot, and I went through each notebook quite quickly, but there's a lot for you there to digest and a lot for you to kind of go through and check out. Links to the data sets with all the outputs on there are available for you, and you should be able to follow along with those notebooks. If there's any issues, let me know, because there are, in the README for that GitHub repo, there's a link to our Discord community.